Okay, for this system, it's tempting almost to solve for x and y using the last two equations first. That's very tempting. You could find x and y very quickly that way. But let's use the usual Cramer's rule for this. So anyway, d is equal to 2, 6, 12. Those are all the coefficients in the x column. In the y column you have 3, -5, and 1. In the z column you just have -1 and a 0 and a 0. Those are both zeros. Okay, so we copy the first two columns, 2, 6, 12, and 3, -5, 1. Then we can start our process of multiplying down the diagonals. So this one, 2 times -5 times 0 is of course 0. And the next one is also a 0 because we've got 3 times 0 times whatever is 0. And the last one is a -1 times 6 times 1, which is a -6. Then we subtract the diagonals going the other way, the products of the numbers and diagonals going the opposite way. So 12 times -5 times 1 is 60. And then 1 times 0 times 2 is 0. And the next one's also 0, I noticed, because it's just 0 times whatever is going to be 0. So we end up getting -6, -60, -66. So d for this system is -66. And we have to next find d sub x and d sub y. Or actually, let's just find d sub z. Once we find z, then we can solve this little 2x2 system using 2x2 Cramer's rule. And that'll be the quickest way to go. So again, I'm going to find z first, and then we'll find x and y in a faster way. So we need to find d sub z. It's the same as this matrix, except z is covered with the 0, 4, 0 from the right side of the system. So copying the first two columns, 2, 6, 12, well, I shouldn't put an equal sign there then. So 2, 6, 12. And 3, -5, 1. So multiplying down the diagonals, the first one gives us a 0, because it's just 2 times -5 times 0. Then we have 3 times 4 times 12. Well, 3 times 4 is 12. 12 times 12 is 144. So that adds 144. To our sum here. And then the last diagonal here is 0, because it's 0 times 6 times 1. And then we subtract what we get going in the opposite direction. So that's going to be a 0. And the next one is going to be an 8. So it's 0 plus 8 in there. And the last diagonal is 0 times 6 times 3 is yet another 0. So d sub z is 144 minus 8. And 144 minus 8 is 136. So that's our d sub z. So now we know what the z coordinate is, because z is simply equal to d sub z divided by d. That's 136 divided by -66. And half of 136 is equal to 68. So this is equal to -68 divided by 33. And looks like we're done. So that's the z coordinate. Let's write the solution up here. We don't know what x is yet. We don't know what y is yet. But we know what z is. Negative 68 divided by 33. So we still have to find x and y. And you may wonder why I found z first instead of x, the usual. And the reason is that I noticed in the very beginning that the last two equations form a 2 by 2 linear system. So we can use Cramer's rule to solve that one very quickly instead of a 3 by 3 Cramer's rule, which is a bit of a schluck, you know. A 2 by 2 Cramer's rule is much faster and easier. So to find x and y, we'll just use those second two equations and solve those. So I'm going to erase all of this, which is no longer needed. And we'll think of the system, we don't even need this first equation anymore. Those two suffice to solve for x and y. So we need a little 2 by 2 determinant for d, and that's just 6, 12, the x column minus 5 and 1. And for a little 2 by 2 determinant, all you have to do is multiply these diagonals, 6 times 1, which is 6, and subtract the product of the other diagonals, which is 12 times negative 5, which is negative 60. So this d is equal to 66. That's interesting. Now, to find x, we find d sub x, where we use 4, 0 to cover up the x column, the y column remaining the same. And so we end up with 4 times 1 minus 0. So it's 4 minus 0, which is 4. So this allows us to find x. X is equal to d sub x divided by d. So that's 4 divided by 66, which is 2 divided by 33. So the x-coordinate of our solution here is 2 divided by 33. Finally, we can find y by putting 4, 0 over the y column of this little d. So 6, 12 is the same, the x column is the same as it was. But instead of the y column, we're going to use 4, 0. So we have 6 times 0 is 0, minus 12 times 4 is 48. So d sub y is negative 48. And that means that y will equal d sub y divided by d, which is equal to negative 48 divided by 66. And that's equal to negative 24 divided by 33. And 3 goes into 24 8 times, and 3 goes into 33 11 times. So the y-coordinate of our intersection point is negative 8 elevenths. And we'll add that up here to our one missing coordinate. And so this is the intersection point of those three planes, the solution to this linear system.